Now, this is an important question in ionic equilibrium where we have to find the ratio of a acid to its anion at a second equivalence point. Now, when we talk about say equivalence point, it's a point where the millimoles of acid is equal to millimoles of base. So entire acid and base is converted into salt. At that point in the solution only salt is present. Now what they have given is a tribasic acid, and that is H3A. So H3A is going to dissociate at three different stages. This is Ka1, Ka2 and Ka3. Note over here that Ka2 and Ka3 are very small values, right? So this will be the stage 1 titration, and this will be the stage 1 where H3A plus OH minus coming from NaOH reacting to give us H2A minus plus H2. At second stage, this salt formed from the first react with further, because it still has a replaceable hydrogen. It reacts with NaOH to give us Ha2 plus H2. So at second equivalence point, this salt will be the only thing which is present. And now we can see that Ka2 and Ka3 values are extremely small. So what we say that for the intermediate stage salt, the protonation and deprotonations are equally likely. And you know, when you put a salt right of the intermediate dissociation state of acid, so the protonation and deprotonation are equal likely, and we get pH by taking 1/2 of that corresponding pKa values, 1/2 pKa2 plus pKa3. So if I put the value, because pKa2 is a negative log of 10 raised to power minus 8 comes out to be 8, and pKa3 is negative log of 10 raised to power minus 12 comes out to be 12, so it comes out to be 10, which means that at the end of stage 1 and stage 2, when the titration has happened, at that point H plus in the solution was 10 raised to power minus 10. Now remember the third stage, which is Ha2 minus dissociating to give us A3 minus plus H plus. For that dissociation constant Ka3 is very small. So we can assume safely that in entirety H plus concentration is of this order, 10 raised to power minus 10. Now since we have to analyze the ratio of H3A to A3 minus, so we talk about the overall reaction, which is H3A dissociating to give us 3H plus and A3 minus. So this is basically, if I talk about say K for this overall reaction, that will be Ka1 into Ka2 into Ka3 is equal to concentration of H plus raised to power 3 into A3 minus upon H3A plus. So if I take this term with the ratio which I want to find on the left hand side and these terms on the denominator of the right hand side, and put the value, I get ratio as 10 raised to power minus 7. Hence for this question, answer would be 10 raised to power minus 7. Thanks for watching the video.